Welcome back, everybody. Today we're going to do some trig values in the calculator, and we're going to do its inverse. As soon as I can get this fixed, here we go. All right, so when you look at the picture, establish what trig function you have based on the sides that you know or the sides that you're told. So if this is your angle, this is the opposite side, which makes this the adjacent, and of course 30 is the hypotenuse. So we have adjacent and hypotenuse. If we think about SOHCAHTOA, adjacent and hypotenuse uses cosine. So that's how you know which one to use. So we have cosine, and then the angle follows immediately, 23. I don't know why I can't write, sorry. And then you follow the ratio, adjacent over hypotenuse. When the x is on the top, you're going to multiply. And you always put this number in the calculator first. So it's 30 times the cosine of 23. Make sure that you go to mode and that you're in degrees, because radians is a different value and you get a different answer. So we want to be in degrees. Since the angle's in degrees, that's how you know. So we get, we're going to, looks like the nearest hundredth according to the directions, so 27.62. There are no units in the picture, so we don't have any units. For number 2, angle, so again, this is the opposite, which means this is the adjacent and this is the hypotenuse. So again, we have adjacent and hypotenuse, which is cosine. And then the angle follows immediately, and then you do adjacent over hypotenuse. Now, when the x is on the bottom, we're going to divide. And you always start with this number over here. So it's 3 divided by cosine of 64. You don't have to add any additional parentheses or do anything fancy to it. Put that in the calculator, and we get 6.84. Please make sure you try these in the calculator. Make sure you're using the calculator correctly. For number 3, this is opposite, which makes this adjacent. So opposite and adjacent is tangent. So tangent of 41 is equal to 15 over x. And again, x is on the bottom, so you divide 15 divided by tangent of 41. So for this one, we get that x equals 17.26. That's how we find side lengths. Now, to find angle measures, we have to tell the calculator to look it up backwards, or the inverse. So when you do second in any trig function, on your screen you get sine to the negative first. This is how you find all angles. So the inverse, which is that 1 to the negative 1, is how you find the angles. Inverse angles. So again, the setup is going to be very, very much the same way. This is opposite, so that means this one's the adjacent side. So we have adjacent and hypotenuse. So when you set this up, we know that the cosine of some angle, we don't know, is equal to 18 over 23. You type it into the calculator, second cosine, and you'll immediately get this on your screen, and you have to put in 18 divided by 23. You don't need to use the fraction key. You can just use division. You can close this at the end or not. That's up to you. Now for this one, we're going to the nearest tenth, and this is theta. So here we get theta is equal to 38.5. Please put the degree symbol on there because we do know the units. Number 5, here's your opposite, and this is hypotenuse. Opposite and hypotenuse is sine. So sine of theta is equal to 29 over 52. And again, it is second sine, and then you type in 29 divided by 52. So the angle is 33.9 degrees. And this last one, opposite and adjacent. So that's tangent. So the tangent of our angle is equal to 17 over 18. Put that in the calculator. Remember, you do second because we want inverse. And you get 43.4 degrees. Now, for angle of elevation and angle of depression, using the calculator will be the same. What's different or what's added is the picture. So angle of elevation, and this is a good picture here, but let's go through it. Let's say here we have, a situation where we have to look up. So the difference from looking straight out to up, this little space right in here, this is your angle of elevation. It goes from straight out to up. We're going to always have a right triangle in these situations, so kind of use that to sort of help you draw the picture. And the picture is probably the most important part, because if you can't draw the picture, it's going to be hard to set up. So here we have a ladder leaning against a wall. So the ladder is what's leaning. So here's my ladder, right? If that helps see it. And my wall is perpendicular to the ground. The top of the ladder is up 18 feet. What angles does the ladder make with the ground? Well, the ladder is also 32 foot long. So this is opposite and hypotenuse. We're looking for an angle, so we know it's inverse. So this is sine of the angle is equal to 18 over 32. So this is going to be second sine because of the inverse. So the angle is 34.2 degrees. Now there's some things we're going to just sort of assume, like buildings are perpendicular to the ground, people are perpendicular to the ground, trees are perpendicular to the ground, unless you're told otherwise, like it's leaning. So here we have a person standing 85 meters from the base of a tower. Ooh. So we have some sort of tower. This is our right angle, and the person's 85 meters away. The tower's 200 meters tall. Here's my person. So the person is looking for the angle of elevation. So from the person, right, from straight out to up, so my 85 is kind of in the way. Let me get rid of my 85. So the 85 is right here, and this is the angle we're looking for. So we have opposite and adjacent. So this is tangent of theta is equal to 200 over 85. Again, inverse. Angle, we're going to have to round this one, so we'll call this 67.0 degrees. Now, angle of depression. Generally, with angle of depression, we have something up here. A person's on a cliff, there's something going on up here. And we want to measure this from the straight out to down. So they're looking down here on something. And so the angle of depression actually lives kind of outside of the triangle. Again, straight out to down. But because of your extreme knowledge of geometry, these are parallel lines. These angles are alternate interior, and we know they're congruent. So actually, angle of elevation is the exact same angle as the angle of depression. But I'm going to draw the picture like angle of depression, because it might make a little bit more sense. So we're at the top of a lighthouse, and the lighthouse is 150 feet up. It's supposed to say angle of depression. So if the person looks straight out to down, so the angle of depression is 28 degrees. Let's see. What's the horizontal distance from the boat? So here's the boat. Nice boat. And we're looking for this as a horizontal distance from the boat to the base of the lighthouse. And that's all we know. So if that's 28 degrees, then this is also 28 degrees. You really want to get your angle in the triangle. So now we know that this is opposite and this is adjacent. So we have tangent of 28 is equal to 150 over x. Now we know the angle here. This is not inverse. This is 150 divided by tangent 28, not inverse. So this will be measured in feet. We get 282.1 feet. So let's take a look at this one. We have somebody in a tree 32 feet above the ground. The person's up here 32 feet above the ground. And again, we're going to assume the tree and the ground make a right angle. The deer is 57 feet from the base of the tree. Here's the deer over here. Find the angle of depression from Henry to the deer. So straight out to down. Here's the angle of depression, but we know that this is the same angle down here. So again, we have opposite and adjacent. So the tangent of the angle is equal to 32 over 57. This is inverse, so you go second tangent. The angle, theta, is equal to 29.3 degrees. Now this last one is tricky. It's like a two-triangle setup. And sometimes the setup is the hardest part. I understand that. So we have a scuba diver spots a shipwreck at an angle of depression of 26 degrees. So remember, so the scuba diver, let's put him here. The scuba diver looks straight out to down. Here's your shipwreck. Down here, right? It's down here, it's crashed at the bottom. Angle of depression of 26 degrees. Some other kind of things here's the bottom of the ocean, let's say, or the lake, wherever they are. The shipwreck is located directly below his boat. Okay. So his boat's up here somewhere. Boat. Because I don't know if the diver's on the water surface or the scuba diver, he could be under the water. And so we know that this is, right, directly underneath there. The horizontal distance between the scuba diver and the shipwreck is 120 feet. So if we kind of drop this down, this is the horizontal distance, but so is this. All right, so this is 120 feet. Oh, angle up to the boat is 53 feet. I was like, I feel like I'm missing something. So let me move my 120. So this is 120. And the angle of elevation up to the boat, so from straight out to up, is 53 degrees. What are we looking for? Find the vertical distance between the shipwreck and the boat. Well, this is going to involve two things. We need this piece, and we need this piece. So let's take a look at, I guess it doesn't matter which one we do first. Let's do y first. We have opposite and adjacent. So we know that the tangent of 26 is equal to y over 120. For this one, this is opposite and adjacent again, so we know that the tangent of 53 is equal to x over 120. Then we get these two values. This one is 58.5 feet, and this one is 159.2 feet. Don't trust my picture. When we add this up, this will be the total distance, 217.7 feet. So that was a weird one to set up. So you got to remember, like, some things are underwater, which would create angle of depression.